Hi, in this video I'm going to show how to do high-load testing, but not high-load, but just load testing. On the server, we will use Docker, Tomcat, Java for server application, Grafana for monitoring, and K6 for loading testing. We will have different RPS load, and we'll have 2 gigabytes of heap, and I have M2 Max chip on my laptop. Let's move further. Here we have the application in the IntelliJ IDE. Here is the application YAML file that serves to have settings of the Tomcat server. Here are the default settings for accept count. It is the queue for the waiting line. Here are the max connections. It's like for TCP connections. And here we have the maximum value of threads for the server. By the default, we have 200 threads. It means that server can handle 200 RPS, but we will use 400 for this beginning test. Here I have several files. For example, this one for 400 RPS load, and the last one for 10,000 RPS. And for the beginning, we will check this one with 400, and then we will go to the 100, and then for the 10,000, and we will check the behavior of the server. What about the request that we are going to test here? Call 120 ms. It is the testing application here, demo controller. Here we have the endpoint. Here it is, and we have thread sleep, delay, and delay for 1 second here. 1 second, and then just return something, just status, yeah. And so we have everything to run. We have Docker here. Here is the application, and let's do the work. Now I have to be sure that we have the current instance image in the Docker. Let's build it. Okay, it's done. And now let's run the test with 400 RPS. It's easy. It's easy. Here we see the work. Yeah. And let's wait for the results. Before it, we can go to the Grafana. Here is the Grafana, and what do we see here? We see requests per second, we see latency, Tomcat current threads, yeah. Busy threads, Tomcat max threads, its table configuration, and what do we see here? Open connections, 500 and a little bit more. And we have threads in the line here, means that they are going to be processed next. We have amount of heap allocated and filled, just 6%, and the maximum is 2 gigabyte of memory. Amount of JVM threads, 400, yes, take a look. The amount was increased since we started the test. Here are some other parameters, but they are not required for the monitoring that we have now. And we have something in the process, yeah, in time. Take a look. Amount is stable, 400 threads in line in time. And we see that amount is decreased simultaneously. It means that test was completed, I guess. Yes, it was completed, and take a look on the report here. What do we see here? We see that test was passed and it fulfilled the requirements because 95 of requests, the time, yeah, for them was less than 5 seconds. And here is the average time for the request. Here is the average RPS, 337, and some other information that you can read if you want. Let's move further. And further, we will run our test with 100 RPS, which means requests per second, and we will increase amount of threads that we will use for that work. To do that, we have to update our build in the Docker container. Let's do it right now. We do it. What else do we have here? And then we will compare some results. The main work here is to show you that the server can handle more than just default value of threads on your server, and you can change your settings to handle a huge amount of threads and requests per second. So job is done, and let's continue for 1000 requests. Okay, and job is started. Let's return to the monitor, and we have new value of 1K here, and we see that this value was increased by our build. And what else do we see here? We see open connections, 100 and 1500. Interesting observation that this value is bigger than amount of requests. Yeah, it's because we have a bigger amount of users here, allocated virtual users that send these requests. All these settings are here, and this setting, for example, means that we send all of these requests per second. Then we see increasing parameters here in the monitors. Busy threads 1000, current threads 1000, latency increased. Yeah, it means 99% of requests length in time. Yeah, length in time 1.2 seconds. Here we have 1000 requests per second. Here is this value. We see the increased gap between 400 and 1000. I love it. What else? We see that amount of heap that is filled, yeah, without threads is doubled. Yeah, it was 6, now it's 12 and 13. What else we have? We have pause time and garbage collector. Okay, it's another one. We have JVM threads, 1000. And what's interesting here that it's a stable parameter. Yeah, 1000 threads in JVM, 1000 in max threads, in busy threads, in current threads, and in RPS. So it's stable. It's what I love. It's what most of engineers enjoy, and of course, businesses. It's predictability. So we see here, yeah, that tests were finished. Let's take a look closer. What do we have here? Status 200. It okay. Okay. We see average RPS 839. Total proceed requests. Okay. And some additional parameters. Okay, it works. It proves that one server can handle 1000 requests per second, but actually in our test it's a little bit less than 1000. Yeah, it's because we see average speed here. Let's move further with another one test. Let make it bigger. Yeah, make this pool bigger. 10,000 requests. And what's interesting that it's going to be more than max connections. But I know that it is the default value for amount of open connections on the server, and it's not recommended to increase this value. But just for this experiment, let's make it bigger. And let's rebuild the image that we have, and we will just take a look on the monitors to fulfill our curiosity of what will happen with the system and what to expect in these circumstances. Because it's just one server, it's not a balanced system without any load balancing, but we want to identify what the maximum value we can fetch from this machine. And now we will run test with 10,000 requests. It is here. And let's start. And let's take a look. What will we get here? We see that amount of threads was increased here, 10,000. What do we see here? Pause time was increased. JVM threads now 4K. Okay. Connections open 10,000. Okay. Max threads here, busy threads, current threads. We see the size of requests now 2K. We see variety of parameters here. Yeah, take a look. And what else do we see here? Take a look on the load of the CPU, 54%, 66% of memory heap. And it's false. Take a look, yeah? Maybe there is an error. Maybe there is an error. Yeah, take a look at this poll. Let's see the test here. Error, yeah. It fall with the error. Take a look on the log here. and take a look here, we see that only 97% were successfully go through the server with the allocated time that we have expected from it, but still some of them were passed. It means that even if some tests, some requests were longer, still it was there in the server, but some of them not. We see request failed, yeah, request timeout means the server drop it, I guess. Okay, what is next? Anyway, we can see the result of the report, and we can fetch some data here. We see that average RPS here was 2,900 requests per second. Looks like it is the limit in these circumstances, of course, because we have 10,000 requests per second, and we can change this amount. We can do something like with different stages, like not just 5,000 at the beginning, but 4 or 3, and then rapidly increase it by, I don't know, 100, I mean, I know, or 1,000, etc. And we will see interesting results. But what we have figured out here is that our server parameters can be changed, and we can handle more than just a default value of requests. We can stress it, we can stress test it, and we can observe the results of our stress testing of this system. To improve it, we can add some new instances, we can add load balancing, we can add Kubernetes, we can spread the values and requests per variety of servers and regions, etc. But I think we achieved the goal of stress testing, how to monitor it, how to test it, how to set it up to be able to handle expected amount of requests and amount of time for each request. That's all. Thank you very much for your time and have a great time. See you. Bye.